In this video, I'm going to show you how to set up your Raspbian operating system on your Raspberry Pi, either in emulation or as a hardware device, in order to do assembly language programming. So the first thing you'll do, if you're using an actual hardware device, you need to go to the Raspberry Pi website and you need to download the operating system and store it on an SD card. So there's actually a bunch of different files here. The one you're going to be interested in is noobs. What noobs is it is a SD card image that is set up to basically choose which operating system you want to run, and then it'll do that installation for you and reside the SD card and so on and so forth. So when you download noobs, you can actually select any of these operating systems here to install. So there's a lot of options here for Raspberry Pi. There's Ubuntu Desktop, there's Snappy Ubuntu Core for mobile devices, there's OSMC, OpenELEC, and so on. The most popular one by far is Raspbian, and that's what we're going to be using. So if you're using a hardware device, you need to download this file and follow the instructions and flash it to the SD card and then boot from that SD card. Now, if you don't actually have a Raspberry Pi hardware device, you can run this in an emulator just fine using Windows, Linux, or Mac. In this example, I'm going to be showing you how to run it on Windows 7. And what you're going to need to do is to go to SourceForge and download this project, which is Raspberry Pi Emulation for Windows. So what this is, it's a package of the same Raspbian operating system, basically this file here, a slightly older version of it, but it's that operating system, that IMG file, packaged with the QEMU emulator. So QEMU, QEMU is an emulator for various hardware devices, and this will allow us to run the Raspberry Pi image from our Windows operating system or other operating systems. This particular example is set up for Windows, but you can find and download QEMU for the operating system of your choice. So when you download this zip file, it's a 529.4 megabyte file. You'll unzip it, and when you unzip it, the contents look like this. So when you unzip the file, there's a run.bat. This is what you'll double click on to actually run the image. There's a README which has instructions basically telling you to double click this and run the image. But if you go in the QEMU folder, this is where the setup files are and all the system files. These are all the files that the QEMU emulator is running. And all of these files are actually running this IMG file. This IMG file is the same file that you would download here from the Raspbian website or from the Raspberry Pi website. So basically what it's doing, all these support files here are emulating the Raspberry Pi hardware, and they're running this operating system image, which you could also burn onto an SD card to run on the native hardware. So our emulator is actually going to allow us to run all that on our Windows operating system here. So when we run this, we'll double click on the BAT file, and that will bring up a Raspberry Pi emulation window. Now this window here is exactly what you would see if you ran the operating system from hardware plugged into an HDMI monitor or projector or whatever. So it'll go through here and it'll boot the virtual machine, and we'll allow that to finish. And while it's doing this, I'll explain some of the other things we're going to be doing. So we need to set up the operating system in order to basically use our American style keyboard, because by default it uses a British keyboard. We need to set the language and the locales and all that kind of stuff. But then we also need to install a few different libraries that we're going to use in order to actually do some development. Namely, we need to install the NTP server, and we also need to install the gedit text editor and the Git software repository system. So Git is a system that allows us to actually check in and check out code from source code repositories. So I'm going to show you my own personal GitHub repository from github.com. You can use the Git program that we're going to install to actually fetch code from there, code examples and other files. So the first time you boot into the Raspberry Pi Raspbian operating system, you'll be greeted with this Raspi config window here. So this is only the first time, and it's only to set up initial things for the system. You'll also be presented with this if you're booting from hardware. It's the same thing. So if you're booting from hardware, you'll probably want to go and run the expand root fs command here. What that does is it basically tells the program to resize the partition to take the entire storage space that the SD card has available. We don't need to do that if we're running the emulator because it's an emulated SD card, so there's nothing to resize. But what we do need to do for either the hardware or the emulated operating system is to configure the keyboard, the locale, and the time zone. So we'll do the keyboard first. Now again, the Raspberry Pi was actually designed in Great Britain, so the keyboard is set up to use a British keyboard, which actually is quite different than the American keyboard. The symbols are different, the key mappings are a little bit different, and it can be a big pain to try to use that, especially if you're writing code, if you have an American keyboard. So when this comes up, we'll hit enter to select generic 105 international PC keyboard. That's fine. But you notice here from the menu, it only has English UK available. So we need to go to other. And then we need to find English US. We hit enter. And then we need to scroll all the way up and select regular English US with no other options. And we'll hit enter. Now, the following options from this page are basically hotkey options that we don't need. We can just use the default. So we're going to hit enter, enter, and enter. And then this will return us back to the main menu. Now that we're back at the main menu, we need to go and set the locale. The locale is basically sort of an equivalent to what you would call a language pack in Windows operating system or Mac OS or whatever. It's basically language settings and character sets and all that kind of stuff that allow the system to display and interact with the user in their own language and their own local settings. So these are all the different locales that we have. Notice that ENGB already has an asterisk by it. It's pre-installed. That's English Great Britain, so we don't need that. So we're going to hit the space bar to deselect it, and then we're going to go down and find EN-US, the very first one, and we're going to hit the space bar to put an asterisk by that. We hit OK, and now we want to go down and hit enter on English US to set the English US locale as a default for this system. And this will take just a second. Maybe a little longer than a second. And now our locale is set up to use English US. The final thing that we need to do before we actually boot into our Linux system or set up Raspbian system is to change the time zone. So this is important, as you'll see in a little bit, because we need to make sure that the time settings on our machine, even though it's a virtual machine, are set up correctly. Basically, the main reason for this is because when we're using Git, Git requires the time to be synchronized when it does a checkout for security reasons and for data transfer reasons. So we want to make sure that we have that correct. So we're going to go to US, and then we're going to select Central, and that will set our time zone, and now we're good. So at this point, we have everything we need set up to go ahead and finish and then boot into our Raspbian OS. So we'll hit finish, and then we'll be presented with a console line, and now we're actually booted into Raspbian OS, the non-graphical version. Now, if we want to boot into a graphical desktop environment, we would run the startx command. That's basically telling the computer to start the X Windows environment. X Windows is just what Linux uses to render dialog boxes and program windows and application interfaces and all that kind of stuff. So we don't want to do that just yet because we need to install some other prerequisites, but we will be doing that in a little bit. Now, for our system, we want to install a few things. The first thing we need to install is Ntp Date. That's a program that's going to allow us to update the time automatically without typing it in manually. And then we also want to install Git. Git is the program that we're going to use to download code. Now, we can also install the gedit text editor, but we'll do that in a separate step. Gedit is a nice text editor that you can use to write code, and it's a little bit better than the default LeafPad that comes with the Raspbian OS. LeafPad is fine, you can use it, but gedit is a little bit nicer, so we'll install that as well. Now, since we want to install stuff, the very first thing we want to do is run sudo apt-get update. This command tells the operating system to go and update its package sources. So the way that Linux works is there's a bunch of packages out there, a bunch of open source projects that you can download and execute on your system. And in order for the operating system to be able to go and locate those packages, it has to look at repositories that are out there that basically contain all the URLs for all those packages and all that nice open source software. The problem is that these URLs change basically daily. So if you have an operating system installed and you haven't run an apt-get update in a while, your package sources will be out of date, and then it won't be able to find and download code as it needs to. So you run sudo apt-get update, and that will go and update all those package sources and update your system, just the sources. Now the sudo part of this command is important if you're not familiar with Linux. Sudo is telling the system that you want to run this command with administrator privileges. Linux by default assumes that you don't have admin privileges, so when you run any kind of command that makes changes to the system, it basically won't let you do that without admin privileges. So sudo does that, and then this command here, sudo apt-get update, is saying I want admin privileges for the apt-get program, and then I'm passing in the variable update to apt-get. So apt-get is the program, and then update is the action that you're telling apt-get to perform. So sudo apt-get update together is saying run the apt-get program with the update parameter with the sudo privileges, and that should allow us to actually perform this. If we didn't put sudo here, we would get some message about not having the proper privileges or permissions, and basically we just get the error and we wouldn't be able to move on anymore after that. So we'll wait for this to finish. The reason why it's taking so long is because this particular operating system image is from 2012, I believe. It's now 3 or 4 years after that. So it hasn't been updated in a while, so it has a lot of stuff to update. But every time after this that we run it, it should update much faster. Okay, now that the apt-get update has executed successfully, we're actually ready to install some stuff. When we install something, we use apt-get, but instead of using the update command, we'll use the install command. So we're going to do sudo apt-get install, and with this line, we're going to install ntp date. This is a program network time protocol that will allow us to basically update the time of the system using a command line versus typing in the time manually. This is important because we need the time to be as accurate as possible in order for Git to work correctly. And then we're also going to install the Git library, or the Git program. So you can install multiple things on one line. Eventually we'll install gedit, but we're not going to do it in this particular command line. We'll do it a few after this. So we'll run this, and it's going to go to the repository sources that we just updated, and it's going to find all the stuff it needs to install. So now it's found what it needs to install, and it's saying that it needs 14.1 megabytes of additional disk space, so we'll say yes, and we'll allow it to actually begin the install. So now it's going to those repositories that we updated in the previous command line, and it's downloading the new files, and then it's going to install everything for us. And when it's done, we'll have the program ntp date and git ready to use installed on our system. So this is different from, say, the Windows operating system, where you go online, you download an executable file or an MSI file, then you double click on it and you run it and you do the installation. Linux basically handles most of this through a command line. There are still situations where you do need to download an executable file or an installer and manually run it, but for the most part, everything that you need in Linux you can do through the command line, which is quite nice. Okay, so now we have ntp date and git installed. Before we can use git, we need to install, or we need to update the time. So in order to update the time, what we're going to do is run sudo ntp date, and now we have a choice here. So usually you would use a time server, a publicly available time server, which would be time.nist.gov. Now, I'm on the UTA network and I expect this line to fail. The reason is because UTA blocks external NTP traffic because network time protocol traffic can actually be used for denial of service attacks. Now, they block it, however, they allow an internal time server, which is time.uta.edu, which should work fine. So this is common for like corporate networks and large networks and stuff like that, just for security reasons. So I'm going to go ahead and run ntp date to update the time with time.nist.gov, which should work from your home internet connection or wherever, and I expect it to fail, but I just want to show you what the message will look like. Okay, so it's complaining about the socket being in use. That's because we need to run it with a -u here. No, I'm sorry, it's not that. We need to do sudo service ntp stop. Okay, so that will stop the currently running NTP background process that was running, keeping us from running that command. So now that I've done that, I should be able to run the ntp date command with time.nist.gov, and I expect this to fail because it'll be blocking the traffic. So when I run this, it's trying to hit the time.nist.gov server right now, and you can see it's not making any progress. Yeah, no server suitable for synchronization found. So that means that we're not able to hit time.nist.gov, but let's try time.uta.edu. Okay, so we can see here that the time was updated. It's now July 21st. That's correct. And the previous year was 2012. Now it's 2015. You can't see it from this line here, but it's updated the time correctly. So now we should be able to use Git. So now, since I stopped the NTP server with the sudo service ntp stop, I want to restart that. So I want to do sudo service ntp start, and that'll restart the NTP server. You don't have to do that. You could just reboot the system, or you could just not even worry about it. It probably won't make a difference, but just to make sure that we have everything running the way it should be, I'll go ahead and run that line. Now, at this point, I could go ahead and install gedit. I'm going to not do that right now and just use the LeafPad editor for the time being, but I encourage you to install gedit. It's a nice editor. You don't necessarily need to use it on the Raspberry Pi, but if you're using any kind of a Linux system, it's my editor of choice at least, but LeafPad will be just fine. So for now we'll forego installing gedit, but if you did want to install it, you would type sudo apt-get install gedit, and that would install it for you. So if I run this, it's going to say it needs probably 70 megabytes or something. Let's see. Yeah, 78.4 megabytes. I don't want to do that right now just for the sake of time, so I'm going to say no. Okay, so now we're actually booted into our system, and we've installed Git and ntp date. We've updated the time, so now we should be able to check out some code. So I'm going to go ahead and boot to the graphical desktop environment to show you this. So I'll run startx, and this will bring me to the graphical desktop environment. Now, all of the commands and stuff that I ran, I could have done that from the graphical desktop environment. It's just for speed and all that, I prefer to use the console. But if you prefer the graphical desktop environment, that's fine. If you want to bring up a console window, then you just double click on LX terminal, and that'll bring up the same console window that we were using before, like this. Now, this icon here at the bottom is the file manager. This allows you to see, it's kind of like Windows Explorer. It allows you to see all the files that are on the system. Home/Pi is where we currently are. By default, it has the desktop folder, which is what you see on the desktop here, and it has a Python games folder. We don't need that, so I'm going to go ahead and delete it, but you can keep it on there. It's not a big deal. And like Windows, that will send that folder to the trash, although it's not allowing us to display it at the moment. Okay, well, forget about that right now. Okay, so here we are in the user folder, and what I want to do now is download some code examples in assembly and actually do the assembling and compilation and actually execute that code. The examples I have are on GitHub, and we installed Git, so we should be able to check it out. So if I open up a command line window, by default that command line window will execute in my home folder. So if I type the ls command, that will show me all the contents of the current folder that I'm in. Then I should see desktop. So we're in the console window, we're executing in this folder here. So when I do the git command to clone my repository, I should see it appear in this folder. So if I do git clone https:// github.com/c.mcmurrow/teaching.git, that will go to my teaching repository and check out the code. Now we can see the teaching folder appeared there, and if this works, it should fill the folder with code examples and files and stuff. Okay, something's not working here. Let's try that again. Okay, there it goes. Okay, so it didn't work the first time. Sometimes this will happen if it tries to hit the server and the traffic is too high or whatever. If you're ever trying to do something from the command line that actually has to go through the internet and it fails, just run it again, because a lot of times it's just a traffic or a communication issue. It doesn't mean there's necessarily anything wrong with your Raspbian install or your operating system install. So if we look in the teaching folder, we should have a bunch of files in here. The file that you're going to be interested in, now this is examples for a lot of different projects, but you're going to be interested in assembly. So if we go there, we see hello world.s. If we open up hello world.s with LeafPad, again, LeafPad is a text editor. It's a very simple, basic text editor. You can look through the code here. I prefer gedit, but LeafPad is fine. If you want to install gedit, you can, but LeafPad works perfectly fine for our purposes. So now we have the code in here in this teaching and assembly folder. So what we can do, if we go back and we run ls, I'm going to go ahead and close this. So remember, we're still in our home directory here. So we've downloaded the teaching folder. I'm going to go ahead and make this full screen. We downloaded the teaching folder. So if I do cd teaching, I can go within that folder. If I do ls here, I get all of the folders that are in the teaching folder. So I'm going to cd now into assembly, ls again, and that shows me the files. So what I want to do is assemble and link and then execute the hello world.s file here. So I'm not going to really go through the code or anything. If you go to github.com/cmcmurrow/teaching in your web browser, you can look and you can see the code and look through it again and see the explanations. But anyway, this is going to just be the final words here where we actually assemble this. So when you want to assemble some assembly code, first thing you have to do is actually do the assembly. So you're going to type in as-o, that's saying I want to make an object file of the things I'm assembling. And then you need to give it the name of the object file you want to create. I'm going to call it hello world.o. This is a file that doesn't yet exist. And then as an input, I'm going to give it hello world.s. Now, if I run ls, I should see hello world.o. This is the object file that has been assembled from this hello world.s. In other words, the GCC compiler, at least the assembler part of the GCC compiler, has gone through hello world.s and it's translated that into machine code and put it here. So it's almost ready to run, but first we need to link it to the operating system and any other object files that it may need. In order to do that, we need to call the linker. So we're going to call LD, which is a linker. We're going to give it the O keyword again, the O flag. And then we're going to give it the name of the executable we want to create. So we're just going to call it hello world with no file extension. And then we want to give it as input hello world.o. So what this is saying is create an executable, in other words, link all these object files into one executable called hello world from this object file here. And we could add other object files if we wanted to. So we could have an assembly program that had many different object files and link them all together into one executable and then run it. So when I run this, if I run ls, then I should see hello world here. Notice it has a different color. That means it is an executable. So if I want to run it, I'm going to type in /. That says execute something in the directory where the command line is currently executing. And I'm going to run hello world, and hopefully I see the words hello world when I run this. And it did. So that shows you the whole process of how to get your Raspbian OS set up, how to take an assembly, or basically how to download some example code from GitHub, how to assemble some assembly code, how to link it, and how to actually perform the execution. So now you have all the knowledge you need to actually start out developing your own assembly code. So if you stay tuned, we'll have some more examples later on of, more code-specific examples of things you can actually do in Raspbian and Linux using assembly, and we'll explain more in depth what the system calls are and some of the intricacies of ARM assembly and things like that. But for now, you should be able to get started now developing on the Raspberry Pi.